With the problem, a stone is thrown upwards with the speed u, attains maximum height h. Another stone thrown upwards from the same height from the same point with the speed u, 2u, then maximum height capital H. What is the relation between small h to capital H? That is they are asking. Uh, Now here you can see. So already we know the formula maximum. So maximum height equal to u square divided by h. U square divided by. So here they are keeping g is a constant. Then maximum height is directly proportional to u square. From this equation you can write as so maximum height in first case divided by maximum height in second case, that must equal to so u1 square divided by u2 square. Therefore maximum case in first case. See maximum case maximum in the problem. So you need to check with if you are projected with the speed u and it attains the height is h. Attains height is h. And if you are projected with the speed 2u, it is for maximum height is 2. Therefore, from this equation, maximum height is small h and small h divided by capital H. Small h is a maximum height when velocity is u, so u squared divided by capital H is the maximum height when velocity is 2u, so 2u whole square. Therefore, you can extend this one. So you got u square divided by 4 times of u square. So u square and u square get cancelled. So then you got so capital H equal to 4 times of capital H equal to so capital H equal to 4 times of small h. So your answer is option 3 with the correct. Second one you can see particle is moving along x-axis whose instantaneous speed is given by v square equal to 108 minus 9x square, then acceleration of the particle. So you got the formula v square equal to 108 minus 9x square. Then acceleration of the particle here you can see already we know that acceleration v equal to whenever velocity is a function of position, you got v equal to dv by dx. So v into dv by dx is your acceleration. Therefore, if you differentiate on both sides, you got 2v times of dv by dx. So that equal to minus 18 times of x square. So therefore, v into dv by dx. So v into dv by dx you can take it minus 9 times of x square. So minus 9 times of x square. Here the option is not there. Then you can go with the option 4. Next question you can see the ball is released from the top of a tower of height h. So it takes time t to reach the ground. What is the portion of the ball after time t equal to h by 3? So use here let us you can take it is a ground and here certain amount of tower is there. Height of this tower is h. And initially the ball is released means initial velocity equal to 0 and it is reaches the time t to reach the ground. Capital T. Capital T with the time of time to reach the ground. Then at a certain position from the ground or what is the position of ball. So position of ball from the topmost point you can take as x. So we know that displacement traveled by the body so equal to so ut plus half at square and here A body is dropped, initial velocity equal to 0. So our initial direction of motion is in downside. Therefore, S value we need to take next to as a positive, and A value also we need to take next to as a positive. Therefore, X equal to AT square, and C at a time T by 3, position is X. So from this equation, acceleration due to gravity is remains constant. Therefore, you can take in X is directly proportional to T square. So then X value we need to find out divided by capital H, a small h they are given. At the position of X value, time is T by 3, and at the position of H is time is T whole square. Therefore, you got T and T get cancelled. You got 1 upon 9. Therefore, X is nothing but H divided by 9. So if it is H divided by 9 from the point of projection, then from the ground you can take in. So H minus H by 9, then you got 8H by 9 from the ground. So this much height it having. Therefore, option you can go with 3. Problem. The relation between time and distance is, so they are given time t equal to a x square plus b, beta times of x, means alpha x plus beta x. The retardation is given by. First, you can differentiate. So differentiate with respect to time. So with respect to time. Then what do you got now? Velocity you got. So differentiation of time with respect to t is nothing but what? Therefore, 2a x times of dx by dt, dx by dt plus beta times of dx by dt. So here you got, from this equation you got dx by dt. So dx by dt equal to 1 upon, so 2ax plus beta. Take this equation number one. Next. Again, if you differentiate, so differentiate again with respect to t or with respect to time, then we got, so here differentiation of constant is 0. That must equal to, so 2 times of alpha. So 2 times of alpha if you are common out now. So it is UV method. First, if you differentiate x with respect to time now, you got v square, you got this dx by dt whole square plus, if x treated as v as a constant and a differentiation of dx by dt now, you got an acceleration. So you got an acceleration E. So a times of u, that plus, so beta times of, already dx by dt is an acceleration velocity, and again differentiation we got an answer. So from this equation you can take, so 2 alpha v square plus a times of 2 alpha, so here I'll written, so 2 alpha v square plus a times of 2 alpha x plus beta, that must equal to 0. From this equation, A equal to 2 alpha v square divided by 2 alpha x plus beta. So already you know that 1 divided by 2 alpha x plus beta is nothing but a v. From this equation, you can take acceleration A equal to 2 alpha v to the power of 3. So 2 alpha v to the power of 3, na? You can go with the answer 1. Next question. Moving with a speed of 9 meters per second. A police chases him on a motorcycle moving at a speed of 10 meters per second. See here, theft you can take. He is a thief, taken as a thief. He is moving with a speed 9 meters per second. And a policeman. So here you can take in one person. He is a policeman and he is moving with a speed 10 meters per second. Now, initial separation between them, they are given 100 meters. Initial separation between them is 100 meters. How will it take for a policeman to catch the theft? means just you can take in time t is nothing but so distance in relative separation between them divided by relative initial velocity. Why? Because relative acceleration equal to zero. That's why bodies are moving under a constant velocity. Therefore, relative separation. Relative separation is 100 meters and relative velocity. Relative velocity. So velocity of police with respect to theft done. So velocity of police minus velocity of are thief. Therefore, velocity of police you can take in 10 and velocity of thief you can take as a 9. Therefore, you got 1 meter per second. So therefore, time taken here it is you got 100 seconds. So go with the option 4. Now, one more question. A drunkard is walking along a straight road. He takes 5 steps forward and 3 steps backward, and so on. Each step is 1 meter long and takes 1 second. There is a pit on a road 11 meters away from the starting. The drunkard will fall into a pit. Now, initially he starts from here. Let us you can take in like this straight road. And 5 steps backward he is doing 5 steps backward and 3 steps. Now 5 steps forward and 3 steps backward. 3 steps backward. Then within 8 seconds, he is traveling only 2 meters forward distance. There is a pit on the road 11 meters. Now here you can take in it is over 11 meters. From the 11 meters, 5 meters back we need to consider. So 5 meters back now, and it is the position of 11 minus 5, you got is 6 meters. Means, so these 6 meters you can divide it into 3 parts. So here 2 meters and here 4 meters, then 6 meters. From 0 meters to 2 meters, he is taking a time is 8 seconds. From 2 meters to 4 meters, he is taking a time is 8 seconds. From 4 meter to 6 meters, he is a time 8 seconds. But for 6 meters to 11 meters, he is a time taken is 5 meters. Once he is reaches the pitna, he does not come back to the back position. That's why total time of flight you can take in. So 3 into 8 second plus 5. Therefore, uh, 8 threes are. So 8 threes are 24 plus 5. Therefore, you got 29 seconds. Go with the option 1. Next question. A ball is thrown from the top of a tower in vertically upward direction. Velocity at a point h meter below the point of projection is twice of the velocity at a point h meters above the point of projection. Find the maximum height reached by the ball above the top of the tower. Let us you can take in it is your ground and tower height you can take next to be as tower height is taken as to be as uh, capital capital H. Tower of height is capital H. So here one body you can project it downward, projected a body thrown from the top of a tower vertically upside with a certain initial velocity. Now velocity at a point h meters below, so small h meters below the point of projection. A velocity is twice the velocity at a point h. Now here you can take in velocity is 2 times of v and the same height h height above the ground is and here velocity is v. Now you can apply kinematic equations. So here initial direction of motion is acting upside. Therefore upside quantities we need to take as a positive. Downside quantities we need to take as a negative. Therefore a value we need to take as a minus g. Height above the point of projection taken as a positive. Height below the point of projection taken as a negative. Now here velocity is acting downside. Therefore minus 2v whole square minus initial velocity u square that must equal to so 2 times of minus g into minus h. So from this equation you got 4v square minus u square that equal to 2gh. So take this equation number 1 for the down case. So it is case number one. For the upside case, for the upside case, the final velocity you can take in positive minus initial velocity is also positive. That equal to 2 times of acceleration is acting negative and height we need to take next to as a positive. So here you got minus 2gh. So take this equation number 2. So now if you add equation 1 and equation 2. So if you are adding equation 1 and equation 2 na, so 5 times of velocity v square that must equal to 2 times of u square v got. Take this equation number 1. So now from this equation just you can eliminate. So if you are eliminate v square value, so no need of this equation. Now equation 2 you can multiply with 4. See equation 1. So equation 1 minus 4 times of equation 2. Then you got equation 1 is 4v square minus u square that equal to 2gh. So 4v square minus 4u square that equal to minus 8gh. So if you are subtracted these two now, so subtracted these two, so you got 5u square equal to 10 times of gh. From this equation, u square by 2g. So u square by 2g, that is your maximum height. So from this equation, u square by 2g is nothing but 5h. So u square, now here 3u square we need to got. So 3u square, therefore 5h divided by 3. So 5h divided by 3. So hence option 3 will be the correct one from this equation.